Now let's review some of the concepts that we've learned. We're going to simplify some exponential expressions. We are going to do a real-world problem involving exponential growth or decay, and we are going to graph an exponential function as a review. Let's start with simplifying exponential expressions. Remember, we want to leave all of our exponents positive. So, we're on the back. Look at problem number 1 of the review. Now, whenever you have parentheses like this, and then something happening, an exponent or what have you on the outside, I always recommend that you simplify the inside part first, then worry about the outside part. So, what can I do with these b's? Hopefully you're thinking, I can simplify those b's. Those are going to cancel and become b to the 4th power. Okay, now I've still got this negative 2 out there. But this is going to become b to the negative 8 power. Anytime you've got a power to a power like this, you multiply. But I can't leave negative exponents, so what am I going to do? 1 over b to the 8th power. And that would be your final answer on number 1. Look at problem number 2. Now look guys, don't get confused simply because I have actual numbers instead of variables. I am not going to multiply 7 times 7 and get 49 here. I'm going to treat this just like I would if they were variables. If I had, for example, n to the negative 2 power times 7 to the, no, not 7, times n to the 5th power, okay, divided by n squared to the 3rd power, that's 5. I'm going to do this problem with the 7s the exact same way I would do it if I had n's. So what would I do if I had n's? Well, when the variable appears twice like this, I add the exponents. So this is going to give me n to the 3rd power. When the variable appears once, and I have a power raised to a power, that's when I multiply. So this is going to give me n to the 6th power. Then I would cancel these 3 n's, will cancel out 3 of these n's. That's going to leave n to the 3rd power, but where? That's going to leave n to the 3rd power on the bottom, in the denominator. What do I need up here, sort of as a placeholder? A 1. So if these were n's, I would have 1 over n to the 3rd power. Guess what? We're going to do the exact same thing with the 7's. I'm not going to multiply 7 times 7. I'm going to add the exponents just like we did with the n's. So I'm going to have 7 to the 3rd power, just adding the exponents. Keep the 7 what it is. So I have 7 to the 3rd power. And then I'm going to have 7 to the 6th power. 2 times 3 is 6. Do not put this in your calculator and just get some number right now. Then these 3 7's are going to cancel out 3 of these 7's, right? Because remember, this really means 7 times 7 times 7. And this down here means 7 times 7 times 7 times 7 times 7 times 7. So these 3 7's are going to cancel out these 3 7's. And that's going to leave 3 7's in the bottom. So that's why I will have 1 over 7 to the 3rd power. Now you could go ahead and leave your answer like this if you want. Okay? If you put it in your calculator, see, what is 7 to the 3rd power? No, that's 343. So you get 1 over 343. Alright, I will accept this as an answer as well. let's look at problem number 3. Let's see. Your eyes should be drawn to two things. First of all, 0 power. If I have x to the 0 power, what is the value of that? Look, x to the 0 power is 1. Not x, 1. So that means I really can just cross this whole thing out because it becomes a big old 1. So it's gone. Now, the y's. What am I going to do when I have a negative exponent like this? So, look, I taught you that anytime you have a negative exponent, that means you have to move it to the other side of the fraction. If it's in the bottom, it has to come up to the top. So it's going to go up there and become y to the 4th power. So let's see what we've got so far. So I had negative 9 and I had 12. The x to the 0 power is 1, so it's gone. Now looking at the y's up here, y times y to the 4th power is y to the 5th power. So that's what happened to all the variables. Now I still need to reduce 9 over 12. Both of these are divisible by 3. So divide by 3, divide by 3. That's going to give me negative 3 y to the 5th power over 4. And that would be the final answer to problem number 3. Let's take a look at number 4. Let's see, let's just do each parentheses separately. Now look, b to the 0 power though, b to the 0 power is just 1. And 1 times anything is itself. So basically, let's just get rid of that. That's just 1. So I'm not going to do anything with b to the 0 power. It's gone. Now with the rest of these, I'm going to multiply the 4 to these exponents. This is sort of like having a to the 1 power. So I'm going to have a to the 4th power, c to the 8th power. I'm going to do something similar here. Again, this is sort of like having c to the 1 power. So I'm going to have b to the 6th power and c to the 3rd power. Let's see. I just need to put all these together. The only things that can go together are the c's. I have 8 c's and 3 c's. So altogether I have a to the 4th power, I have b to the 6th power, and how many c's do I have? I have 11. So this would be the final answer to number 4. Let's do number 5. The first thing you should do, anything with a negative exponent is on the wrong side of the line. So this y to the negative 1 power needs to end up on the bottom. And this y to the negative 4 power needs to end up on the top. So when I recopy this, let's see, I'm going to have y to the 4th power in the top and y to the 1 power, or just y, in the bottom. Now I might as well go ahead and reduce the 15 and the 25. Both of these are divisible by 5. So divide by 5, divide by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. Now, what will become of these y's? I'm still going to have 3/5. Nothing can be done with that. I'm not going to subtract or anything crazy like that. But with these y's, what will happen? I'm going to have y to the 3rd power because they cancel. The extras are on top. So that would be your answer, number 5. Let's see, number 6. Well, I have choices. I can either take this r to the negative 6 power and move it up, or I could add these two together right now. I don't know which way will be easier for you guys. Well, I'm not there to hear your answer, so the quickest way to do the problem would be to go ahead and multiply these, so I'm going to wind up adding these exponents. If I do that, I'm going to get r to the 0 power, because 6 plus negative 6 is 0. And then I've got this negative 3r to the 5th. But we all know that anything to the 0 power is 1. So this whole thing is like having 1 down here. So that basically is gone. So that's just going to leave negative 3r to the 5th power. That's the most direct way to do it. And that would be the answer to number 6. Let's see. If we did it the other way, we could take this, because it's negative, that would mean we would need to move it up to the top. So it will become r to the 6th power if we move it up there. So it's gone now. So that would give us negative 3 r to the 11th power over r to the 6th power. But then we'd keep going. These 6 r's will cancel out 6 of these 11 r's, leaving 5 r's. So that will still give us negative 3 r to the 5th power. So either way, that's the answer to number 6. Number 7. Ultimately, we're going to do the reciprocal when we have a negative power like this. But I recommend first doing what's inside the parentheses. So what will become of these x's? This x in the bottom will cancel out one of the x's in the top. So that's going to leave me with x over 3. I've still got my negative 3 power. There's nothing else to do on the inside. So when I have a negative power on a fraction, I know that I can do the reciprocal. So this will become 3 over x to the positive 3 power. Then I will just cube both of these things. That's going to give me 27 over x to the 3rd power. So that would be the final answer for number 7. Okay, number 8. It looks a little scary, but it's not. Don't be nervous. When you have two fractions like this, we're just going to put them all together. We're going to put all the numerators together, and we're going to put all the denominators together. Okay, so if I put all these together, let's start with the number part. I've got 4. Now let's look at the x's. X and x squared. Altogether, that makes x to the 3rd power. Y to the 4th, y squared. That makes y to the 6th power. Down here, number-wise, I have a 2. X's, I have 6 of them, so that's x to the 6th power. I have just y squared. Okay, see, that wasn't so bad, was it? I've put the numerators together and the denominators together. Now it looks like an easy problem to do. I will simplify the rest of it as usual. 4 and 2, that reduces down to 2 over 1, which I won't need the 1. When I look at the x's, what will become of the x's? Well, I'm going to have x to the 3rd power in the bottom after they cancel each other out. Notice I don't divide, I cancel. 3 x's cancel out 3 of these x's. What will become of the y's? It's going to be y to the 4th power in the top. So this would be your final answer to number 8. Okay, let's look at one more example of exponential decay. I know that this is going to be exponential decay because it says the TV decreases by 21% each year in value. So that's what tells me I'm going to use this formula, that the value of this TV is going to equal the initial amount times 1 minus the rate to the power of time. Okay, so this TV's value is going to equal the initial amount which is $1,200, times 1 minus the rate. Well, the rate is 21%, so I'm going to put 0.21 as a decimal. Okay? And it says after X years. So I'm supposed to put an X here. Normally we put a T for time, but so I would have accepted X or T. This is the model that we were asked to find. Now we're supposed to use the model to estimate the value after 3 years. In other words, I'm just going to take 3 and substitute it in for time. So the value is going to be 1,200 times 1 minus 0.21 to the third power. So I'm just going to put that in the calculator. And really, there's something I should have done up here. This is 1,200. I should have subtracted these and gotten 0.79. That's a better way to write the model. So yeah, definitely go ahead and put 0.79 up there. So the answer is going to be $591 and 65 cents. Okay, that's the answer to number 9. Okay, let's see. Now, last but not least, problem number 10. Alright, let's type this into the table area of your calculator. So we're going to do negative parentheses, use your N over D button, use your caret, and then minus 4. So type it into your calculator like that. Look, before we do anything else though, we need to decide what the middle x value we're going to use. So remember, we want the x value that will cause this exponent of x plus 2 to be 0. What x value will cause the x plus 2 to be 0? Negative 2. Negative 2 plus 2 is 0. So we want the middle value to be negative 2. So that tells us to put negative 2 as the middle x value like that. That means the other x values will be negative 3, negative 4, negative 1, and 0. Those are the values that we should have. Alright, if you look on your calculator, the other values that we should get are like this. So these are the values that we should get from the calculator. Now it's important to calculate your table first so you can decide exactly where you want to put your x-axis and your y-axis. Look at these y values. Notice how they're all negative. All your values are negative. That means we want the x-axis to be way up high so we have plenty of room underneath for these negative x values. Also, look at the x values. Notice that most of them are negative except for 0. That means the x values are all to the left. So we would like our y-axis to be off to the right to leave plenty of room for these negative x values. So we want our x-axis up high and we want our y-axis on the right. If you didn't understand some of what I said, just experiment with the placement of your x and y-axis. Use pencil and just make sure that all of your points will fit on your graph. If you find your points going off the graph, move your x and y-axis over until all your points will fit. That's the main thing. Okay, so there's my x and y-axis. Now I'm going to plot these points. I've got negative 4 comma negative 8. So in fact, hold on, let me pause this so I can do it fast. You know what, before I plot the points, the asymptote, this number on the end tells me what the asymptote is going to be. So the asymptote is going to be -4. So there's our x-axis. So let's go down 4 and put the asymptote. So the asymptote is going to go right here, down 4. Now I'm going to plot these points very carefully. So these are the 5 values that I get when I plot the 5 points from my table. So I can see that my curve is getting closer and closer to the asymptote from left to right, coming from below. So let me draw that. So your curve should look very much like this. Take care to make sure that your curve does not cross over your asymptote. It should get closer and closer to the asymptote. It's going to even appear to trace on the asymptote at the end, but we know that it doesn't really touch. It just looks that way because ink has thickness. Now the domain, the graph goes left and right forever, so that's going to be -infinity to +infinity. The range, what's that going to be? -infinity to -4. Bottom to top, it must be in that order. -infinity to -4. Make sure you leave a round parentheses on the -4 because it doesn't include the -4. Of course, the asymptote is y equals -4. No matter how many times I say it, somebody always leaves the y off. If you want full credit, you must put y equals -4, not just -4. Now, what's the y-intercept? That's 0, -4.25. The y-intercept is always 0, something. What about the x-intercept? Yeah, it's never going to reach the x-axis. It won't get that high. So the x-intercept, there's none. So we'll just put none. Now, there are 3 transformations that we need to list. Because of the +2, what happens? That's going to be left 2. Because of the -4, what happens? That's going to be down 4. What's the third transformation that I haven't talked about yet? The minus sign in front. How did I say we would describe that transformation? It's going to be a reflection over the x-axis. And that's how it's done.